It's go time. It's go time. Okay, so we have example 2, example 1's on the whiteboard. Can't see. Sorry, Kira. Number 2, solve. Sine theta equals a half. Remember, we're doing easy ones first. 0 degrees is less than or equal to theta is less than or equal to 360. Right? How else could this question be written? We just went over this. How else could it have been given to you? 2 sine theta equals 1. That's one way. They could have had the 2 up with it. Then we'd have to divide the 2 over, right? They could have had 2 sine theta minus 1 equals 0. These are the exact same question, but not helpful in that form, right? We would want to keep going. We have to get into, because they're degree 1. Degree 1 means they have little ones here. You just can't see them, right? Whenever you have a degree 1 sine, cos, tan, cosecant, secant, cotan, whatever it may be, you have to get it by itself, okay? Now, this fraction, again, I said I'm starting off easy. This fraction, again, is on the unit circle. It's sine. Sine is what on the unit circle? Y. So I'm going to look where y is positive because it's sine positive a half. Where's y positive? In quadrant 1 and 2, which is at theta equals, whenever it says solve, you better have variable that they gave you equals some sort of answer, right? Because what does solve mean? Solve means variable that equals some answer. Variable they gave you equals some answer. That's it. So if the variable is an x, I need x equals some sort of answer or answers, right? So if it says solve, that I need to have that in boxed or something at the end, or else you didn't do what solve means. Okay? Yeah, and take all your marks off for not boxing your answer. 0. Circle? Oh, circles? 0. Clouds? -0. I actually really like doing clouds and boxes. They don't care. As long as you draw attention to it, they're happy. If you don't, they have to look for it, but they'll still be happy as long as it's there. Okay. Yeah. So remember, if you box before the answer, though, you're saying that's your answer and it's not your answer, so don't box it. Okay, a half is found where? At 30 and 150. Okay. We're going to get progressively a little harder, but we're going to stay on the unit circle. So 3, solve. Two cos x, because it doesn't have to be a theta, right? 2 cos x minus plus 1, equals 0. Now I have to give you some sort of domain. I'm going to make it a little bit harder. 0 less than x is actually, it's not a degree symbol. I don't want to use my eraser, but I'm going to have to. 0 is less than or equal to 2 pi. Still not hard because they're all on your unit circle, right? But what you do need to recognize is if your domain is in radians, your answer has to be in radians, right? If your domain is in radians, your x answer has to be in radians. So this is a degree 1. What's the very first thing we need to do? Move over the 1. So 2 cos x equals -1. Divide by 2. Cos x equals -1/2. Cos is x. So we're going to look where x is negative, which is obviously quadrants 3 and 4. And where is it a half at? 60-degree reference angles. So it's going to be at 240. I really went there first. Sorry. And then the one before that, it's 120. Cos is the x.
Because it can't be in 1 or 4.
They're possible. No. There is going to be more to do. So when you see that it's on the unit circle, you praise Jesus. You do a little dance in your head, and you just write down the answers and you mosey on. That's what you do. And 120, yeah. We can box it. We can cloud it. Can we do this? Is this right? McKinley, you're right with what you were saying. Don't we have to? Right. This is bad news bears, guys.
I had it, and then I erased it because I was like, oh,
Also, I freaking put a theta. Ah, so many bad things. Yes.
You're one of those teachers.
One of those people. Well, it's called life lessons. I feel like you're holding back. All right. So we're going to have 5 pi over, that's a lie. 4 pi over 3. I went to go do a 30 degree rectangle. 4 pi over 3 and 2 pi over 3. Okay. Right? We agree?
That's much better.
Not crazy. Okay? Okay. Does that make sense? We agree? All right. 4. Solve. Secant theta plus 2 equals 0. Secant theta plus 2 equals 0. Still degree 1, right? So we have to get it by itself. Secant theta equals -2. Secant is the same as cos. Cos -1 over 2, which is the exact same question from before. Okay, I'm going to show you something though. We're going to trick it up. -180 to 180. Whoa. This is not going to be as crazy as it looks. You ready? Okay, we're still going to answer like we did before. Our previous answers were 240 and 120, right? Those were correct. So we're going to go theta because that's our angle. Equals, this really looks like a cowboy, this one. Too funny. 120 and 240, okay? Our first step is to still state the angles from 0 to 360. I don't care that the domain is not. Okay? Yes? Now, all we do is we go back to that lesson where we learned about coterminals and we learned about reference angles because those are what we're going to use today. You will subtract or you will add to find the angles that do fit in that domain. So you find your original domain from 0 to 360. That's great. 120 fits. Okay? Between -180 and 180, it fits. Because -180 to theta is just -180 to 0. So -180, -120, -90, -3, those would all fit in there. And then we go from 0 to 180, right? That's all the -180 to 180 means. So 120 fits. If I add 360, it goes up to 480. Too big. If I subtract 360, it goes to -240. Too big. So 120 is the only one that's going to work. That's coterminal, right? Now 240, does it fit? No. So we have to see if its coterminals do. 240 minus 360 equals -120. Does that fit? Yes. So we keep this one, not the 240. That's all it is. You literally find your normal angles and then just check the coterminals. Yeah. No, because that's not the reason why this is -120. No. It's just because they're in quadrant 2 and 3. It's the only way it's going to work that way. Okay. Ready? Yes. You could go plus or minus 120 degrees. It makes things faster. Okay, 5. Ready? Let's do solve. I went to go write cotan. Solve cotan x equals 0. Now let's think about this. When cotan x equals 0, cotan is cos over sine. Remember, son, you don't need to do cotan and tan together. Cotan is cos over sine. How can I get something to equal 0? Where does the 0 have to be? In the numerator or the denominator? Numerator. If it's in the denominator, it's actually undefined. So what I'm looking for is cotan is cos, technically cos x over sine x, right? So I'm looking where cos x is 0 and sine x is a number, and I don't really care what that number is. So where is cos equal to 0? I'll just do. It's when x is equal to 0, which is 90 and 270. So x equals 90 degrees and 270. If I change the domain, I would literally just be checking for the coterminals. That's it. Looks like some bread that didn't rise properly. No. 0 on the top is 0 into something. That's 0. How many times does 0 go into anything? No times. But when you have a 0 in the denominator, that little fraction line means divided. So it'd be 0, right, into 240. How many ways does 0 go into 240? 0. But if I go 240 divided by 0, like what's that going to do? So like it's divided by. That symbol is a divided by. So if I go like this, just treat it like divided by. If you treat it like divided by, it's way easier. So 240 divided by 0. Can I divide it by nothing? No. 0 divided by 240 means this, 240 into 0. It goes in 0 times. So you can't divide by a 0. Your denominator can't be 0. If your denominator is 0, bad things happen. You should get a math ticket, possibly taken to math jail. Math jail, math ticket, math jail. I should have them freely running. Right. Okay, 6. Solve tan x tan x is undefined from negative 180 to 180. Tan x is what over what? Y over x, same thing. Because sine is y, cos is x, right? So both works. So in order for it to be undefined, what has to happen? The bottom has to be 0. And the bottom, when it's tan, is cos or it's x. So it's where x or cos are equal to 0, which is at what? Those aren't circles, those are zeros. Cos x has to be 0. X has to be 0. No, it's making them be 0. This can be any number. So can this. So when is x equal to 0? 90 and 270. That's what you told me, right? The variable's x. X equals 90, 270. Which makes sense. When cotan equals 0, tan is going to equal undefined, right? Because they're flipped. Now, this is great. However, both of those don't fit. So 90 does. 270 does not. It's too big. So adding an extra 360, probably going to make it way too big. So stop the madness. Don't do that. So I'm going to subtract 360. And I'm going to get negative. It's not always going to. It's because I keep hitting quadrants. And I'm only doing negative 180 to 180. We'll do ones where it's like negative 360 to 0, 0 to 480. Like they can be anywhere. They can just restrict your domain wherever they want. And then in radians as well. So my answer is going to be plus or minus 90. Okay? Now we're going to trump it up, but we're still going to stay on the unit circle. So it's not that bad. All right? 7. Solve. I'll do this. Tan squared x minus 1 equals 0. Paying attention, please. And I'll do 0 to 360 on these first ones. Okay? Tan squared x minus 1 equals 0. The only thing I have here is a tan squared x, right? So this only works when I have a tan squared x by itself, or a sine squared x, or secant squared x. I can isolate it. But if I have a tan squared x and a tan x, I can no longer isolate it. It would just be the same as this. This is the same as saying, okay, I have x squared minus 1 equals 0. I can isolate x squared, right? I can do this. Okay. But if I had x squared plus 2x equals 0, could I isolate the x squared? No, I would have to GCF and x out and solve. Totally different ball game. So only because we just have a tan squared x here can I isolate it. If I have a tan x with it, we're done. Everything to one side. Have to solve it a totally different way. So only when we have a tan squared by itself. So this is the thing. We're going to get tan squared x equals 1. And then what are we going to have to do? Square root, which means we have to plus or minus. And if you forget the plus or minus, you're losing half of your answers. So tan x equals plus or minus 1. So we actually have two separate answers here. We have to find out when tan x equals 1, get all those solutions, and then we have to find out when tan x equals negative 1 and get those solutions. Now tan is what divided by what? Sine divided by cos. Where's the only part on your unit circle where they're the same, where you're going to get a 1? Yeah.
45 degrees, 135 degrees, 125 degrees.
So all the 45-degree reference angles. Because it's going to be root 2 over 2 divided by root 2 over 2, which is 1. Quadrant 2, you'll end up with a negative 1. Quadrant 3, you'll end up with a positive 1. Quadrant 4, you'll end up with a negative 1, right? Because tan is positive in quadrants 1 and 3, and tan is negative in quadrants 2 and 4. And the reason why that exists is you're multiplying or dividing two negatives in quadrant 3, so it becomes positive, right? So tan x equals positive 1, 45 here and 45 here. So my answers are going to be at 45 and 225. Because it's where root 2 over 2 is divided by root 2 over 2. In this one, it's negative root 2 over 2 is divided by negative root 2 over 2. Okay, you should be writing these down. Pick up a pencil, right? And then negative 1 is when you divide two numbers, one of them positive and one of them negative, that are the same. So you get the negative 1. So this one's going to be at 135 and 315. My variable is x. So my answer is going to be x equals 45, 135, 225, 315. Yeah. Yeah. Because it's sine divided by cos. And the only place you're going to get 1 is if your sines and coses are the same. And the 45s have root 2 over 2 and root 2 over 2. So when you divide those two, you get 1. Like 3 over 3 would be 1, 5 over 5 would be 1. The only place on the unit circle where your x's and y's are the same are at 45s. Okay. Try it out. Remember, we haven't went off the unit circle. So if you feel like we have not. Figure out a way to get back on. Okay. So we're going to subtract the 3. So we go 4 sine squared x. So I say grade 3 or grade 10 is so important. This should be minus. Sorry. Minus. The fact that you knew you couldn't take the square root of a negative makes my heart sing. Guys, that makes my heart sing. You can't take the square root if it's negative. You'd be again an imaginary number. Okay, so move the 3. Then we divide by 4. Okay, then we bring grade 10 back here. Sine squared x, grade 10 is so important. I wish I could sell that to the grade 10s. Okay. More in the grade 10. Oh no, it's important. Yeah, you should have a little talk. You talk to those grade 10s. It's very important, right? Every single time I talk, at the end of each thing, there's always a grade 10, and some grade 11, mainly grade 10. All right, we take the square root. We need to remember what? Plus or minus. Now, in grade 10, you were taught that you can have the whole radical over the fraction, or you can split it. The only reason why you would split the radical, though, is if one of them was a perfect root and one of them was not. And in this case, there's a perfect root. So that's why in grade 10, you were shown that, right? So we get plus or minus root 3 over 2, because I can actually write this as root 3 over root 4, which is root 3 over 2, right? Grade 10 taught us that. It was the best of times. It was the best of times. So, root 3 over 2 in sine. Easy to do, correct? But we have a plus and we have a minus. So we're going to get 2 solutions for both in the 360, 0 to 360, and 2 solutions for the other one in the 0 to 360. Because there's 2 places where sine is negative and there's 2 places where sine is positive. So, root 3 over 2 for sine is at the 60-degree reference angles, right? Root 3 over 2 is at the 60s. And it's positive here and here. So I know it's at 60 and 120. Okay. Sine is negative. We know in quadrant 3 and 4, but still 60-degree reference angle. That hasn't changed. So this one's at 300. And this one's at 240, which is great. They actually all fit in the domain. Because my domain is from negative 180 to 480. So I'm done. No. I need to check. I might have more than 4 solutions. Right? So, what do? I check their coterminals. So if I subtract 360 from 60, what do I get? Negative 300. Does that fit? No, negative 300 is too big. So I add 360 to 60 and I get 420, and that fits. They do, but you can have more. Cal? You'll get to fill one in for the test, but your diploma you have to make your own. So we start practicing them on our own. You just get blank sheets back of your test to write whatever you want. Okay, 120. If I subtract 360 from it, I get negative 240. Does that fit? No. If I add 360 to 120, I get 480. Is there an equal sign? Yes. What if I didn't put an equal? Then no. Which can happen. A good prank. Good bad prank, you know? Yep. 240 minus 360. Negative 120. That would fit. If I add 360, I get 600, which is way too big. 300, I subtract 360 and I get negative 60. That fits. 300 plus 360 is 660, and that's way too big. That sounds spooky.
That was good, Halloween.
Thank you. Then we write all of our solutions, but we need to figure out what the heck variable. Ah, good. Not theta. Shh. Negative 120. She's really going to like it when she hears me shushing that loud in her ear. Poor girl. Minus 60. I always go low to high. 60. 120. It makes people's hearts sing when they see it. And markers' hearts sing when they see it in order. Like it just, because it's so much easier to mark. It's surely for my own welfare. The markers didn't make you do anything, actually.
Well, they're choosing.
Teachers didn't make you do a diploma either. Teachers just taught what they had to teach. Just be happy. It's 30%. Used to be 50. Used to be 40 questions worth 50%, and every single question was over 1% of your mark when you wrote the diploma. So let's just put a little happiness in that 30, okay? Let's just put a little joy in your heart. 9. 3 cotan x plus 1 equals 2 plus 4 cotan x. From negative 180, no, you're getting ahead. You're making this even harder.
See, I told you I'd do that.
Okay. Do we have a degree 2 at all? Do we have a degree 2? No. We only have degree 1s. So if it's overwhelming to you, please do this. If you look at it and you're like, oh, I don't even know. What you can do is you can say this, but you do have to write it. You can't just do this yourself. You have to write this. You have to go let, and I always make it an M. You can make it whatever letter you want. I pick M, and I don't even know why. I just do. Let M, oh, for McKinley, yes. All these years, it's been for this moment, Let M equal cotan x. Okay? Yes. This is the only point you actually recognized last year? Wow. Okay. So you go 3m plus 1 equals 2 plus 4m. And now what would you do? Yes, collect like terms. Minus 3m. 1 equals 2 plus m. Subtract the 2. M equals negative 1. Then, when you get to this point, please do not box it and walk off. There wasn't an M. You put the M there. There was no M. Thank you. Cotan x equals negative 1 where? At the same spots as tan equals negative 1. Because you're now just doing cos divided by sine, but it still has to be the same numbers. So where does it equal negative 1? 2 and 4, 45s. Ooh, oh, that's bad. Just pretend that's good. Yes. So this is going to be at 135 and 315, which are great, but we always have to go look at our little domain. Don't have equal sign this time. Tricky, tricky. You also have to check them. These two fit. That's good, right? But some of their coterminals might also fit. So if I take 135, and I subtract 365, I'm going to get 225, which is too big. 315 minus 360, and I get negative 45. And that actually fits. So we have 3 solutions. X equals negative 45, 135, 315. Okay? That was all stuff you did last year. Because almost everything you did last year, especially in that textbook, is all stuff from the unit circle. We're going to do one more thing that's a little bit, you all liked it anyways because you did it last year. But we're going to do this one. Am I on 10? 2 cos squared, sorry, it should say solve. I don't think I put solve on the last one. 2 cos squared theta minus 3 cos theta plus 1 equals 0 from 0 to 2 pi. Okay. We have only until now had just cos squared or tan squared or secant squared or cosecant squared or cotan squared. Just that and then a number, right? So we isolated the cosecant, cotan squareds, square rooted, and we were done. We agree? Remember, if you are overwhelmed, and honestly on this type of question, most people are overwhelmed. So I would just go right off the bat and say, hey, I have cos and I have a cos. I'm going to just let m equal cos theta, not x, because there's no x's. And I'm going to replace. And then I'm back to grade 11. 2m squared minus 3m plus 1 equals 0. What they can do is they could have 2 cos squared x equals 3 cos x minus 1. You'd have to move it all to one side, set it equal to 0. It's just grade 11, right? Every question we do involves grade 10 or 11, always. That's how it works. And if not, it involves transformations from now. That's how we roll. Okay. So we say what multiplies to give us 2 and adds to give us negative 3, which is actually grade 12 and 11 because we learned to factor in grade 10. We learned how to solve factoring in grade 12 or grade 11. So it's going to be negative 2 and negative 1. So we have 2m squared. We're going to replace this negative 3m with negative 2m minus 1m because that is negative 3m. Group our front 2. Group our back 2. Put a plus sign in between because we're not multiplying them. That would be foiling. We take out a 2m and we're left with m minus 1. Take out a negative 1 and we're left with m minus 1 equals 0. Then we say, what can we take out of these two terms? An m minus 1. And what's left over? 2m minus 1. And in grade 11, so that was grade 10, we learned how to factor. In grade 11, we learned, take those two factors, set them equal to 0, solve for the m. Right? So m minus 1 equals 0. 2m minus 1 equals 0. M equals 1. 2m equals 1. M equals a half. People who do this in one step sometimes will write 2 because you just flip them in your head. So I was do 2 steps. Okay, but we weren't actually given an m. We were given cos theta. So we have to go cos theta equals 1. Find the solutions to that. And cos theta equals a half. So it's like doing 2 single trig ratios. Like we were doing them before. We just now have 2 in one question. Our domain is nice. I still give you a nice one. 0 to 2 pi, not inclusive of 2 pi. I could have written it like this, which they sometimes will. Well, it's coming at you, Cleopatra. Just because you don't like it, don't mean it's not going to happen. So we need to find it when cos equals 1. And I gave you a nice step because it's all in the unit circle. So cos equals 1 when x equals 1, which is at 0 and 2 pi. But 2 pi was restricted out of my domain. Not 2 pi, 2 pi. Because it's not equal to. Up here, no equal. Then cos x equals a half at 60s, and cos is positive here and here. So this is 60, and this is 300, which is great answers. Which is great answers. I can't even speak properly. Which are great answers. However, wrong because they're not in radians. So pi over 3 and 5 pi over 3. So when I go to write my solution, I check what my variable is in the very beginning. Oh, it's theta. Theta equals 0, pi over 3, and 5 pi over 3. That one looks like cowboy again. Sine squared x minus sine x, or equals sine x. So some people will try and divide the sine x over or something crazy like that. You can't. You can't divide a sine into anything or else you're getting rid of some solutions. It's a squared and it's not a square that's by itself. So when it's a squared that's not by itself, I told you you have to move it all to one side, set equal to 0. That's not an option. So it's not a squared by itself, right? So we have to go sine squared x minus sine x equals 0. And then what can I do? You can make it m's. So we get m squared minus m equals 0. And then you guys will sit here for life. I can give you the worst decomp and you can figure it out. I give you this, you'll just stare at it. Or you'll divide the sign initially and not stare at it and think you did it right, which is scarier. More scary. So if you can't factor, you were taught in grade 10, GCF. So take out an m. You're left with m minus 1. So it's actually a really easy question that you guys make be really hard or just wrong. Not hard because you like just divide out right away and it's bad. If you would divide the sine x out, guess what, guys? If you're dividing that sine x out right off the bat, you're actually getting rid of this answer completely. You're dividing the sine x off. M equals 0. That's my one factor. It went right here. M minus 1 equals 0. Solve it out. So I have m equal to 0. GCF. Just took an m out. So then you have sine x equals 0. And then sine x equals 1. So sine x equals 0 when y equals 0. So here and here. So it'd be 0, pi, 2 pi, because I made it inclusive. And then sine x equals 1 here. Bless you.
Thank you.
Okay. Tomorrow we do the same thing, but we can't just instantly pull our answers off the unit circle because our angles will be decimals, not perfect solutions. So they'll still be on the unit circle technically, but they're those points that are in between that would connect to make the rest of the circle. And what was the assignment again? Page 357 AC.